Hey kids, okay, part two. So the reason why this video was split up into two parts is because what we did in the last video is pretty hefty in terms of the test points. So I wanted to make sure that people have had a little bit of practice and have had a chance to think about that. Now if you have had a chance to think about that, we can start to answer some word problems. So let's look at this one. Two consecutive whole numbers have a product less than 50. What could those numbers be? So there's kind of two ways you can answer this. I mean, first we better just define what this means. Two consecutive whole numbers. So whole numbers, if you remember, that's 0, 1, 2, 3, going on. So it's the numbers you can count, including 0. Consecutive means one after another. So if one of the numbers was 2, the other number would be 3. Or it could be 6, and it could be 7, or 10 and 11, that kind of thing. So if they're consecutive whole numbers, that's what we're talking about. So what we're going to do here is we're going to think of this in sort of just a common sense kind of way. If you actually listed out all the possibilities, two numbers that are consecutive and the whole numbers have a product of less than 50, you actually probably could sit down and you could work out all the possibilities. In fact, we could say 0 and 1, they have a product of 1. 1 and 2 would be another possibility, and that has a product of 2. 2 and 3 would have a product of 6, and 3 and 4 would have a product of 12. 4 and 5, and you can kind of keep on going here. That's 20. That's 30. That takes us to 42. And if I get to 7 and 8, well, that's, 56? Okay, so we can actually see that we could spend some time to list out the possibilities, and what we would get is we would get this. So what we can see that is the two numbers can be anywhere between 0 and 7, and then this one's too big. Now, of course, we don't always want to do that. If I ask this question like two consecutive whole numbers have a product less than 50,000, then you'd want to do something a little better than listing them out. But it's actually really handy just to kind of have a sense of what the answer is going to be. But let's see how we can actually work this out using the techniques of yesterday. So I'm just going to erase all this. Okay. So if we didn't know the numbers, or if the numbers were too big to work it out just by listing it out, what would we do? We'd first of all have to say, and just like every word problem, we'd say let x equals, and I'm going to call this the first number. That means the second number, oh, maybe I'll actually write this in a different way. Hold on, let's say let the first number equal x. I think this is going to look better. Okay, let the first number equal x. Let the second number equal. And if it's consecutive, that means it's 1 bigger. So we're going to say x plus 1. And we're just going to kind of have it in our brains that the first one is the smaller one. This is the smaller of the two numbers. And then the other one is the larger of the two numbers. Okay, so how can we actually solve this in a mathematical way, going through the steps? So we have to write an inequality. Now, we have two consecutive whole numbers that have a product that has to be less than 50. So we can express this as the first number multiplied by the second number, that's the product. And when you multiply these two together, it's going to be less than 50. Okay, so that's our equation. How do we actually solve this thing? So if we actually look at it from this point onward, this is just a question like yesterday where we have to solve for the values of x that are going to satisfy this. That's going to involve thinking about critical points and all that. So what I'm actually going to do is I'm actually going to go straight ahead and let's find the critical points. So the critical points here would be to multiply this in and get x squared plus x. I'm going to minus 50 to get it over here. And I'm going to say when's that less than 0. So what this is saying is now this guy is a parabola. When is the parabola less than 0? Or when is this parabola ducking below the x-axis? So I need to know the exact points. Now, if you look at this, can you factor it? Let's see, AC equals negative 50, the middle number is 1. Are there two factors of 50 that add to 1? I don't think that's going to work. That's not factorable. Okay. So if it's not factorable, we'll have to use some other thing here. Remember, when you're doing critical points, you're actually setting this equal to 0. You're going to deal with the inequality later. Okay, so what we're going to do is we're going to solve, and I'm going to use, I think I'm going to use the quadratic equation. So x equals, now remember it's negative b, so that's negative 1, plus minus b squared minus 4ac all over 2a. So what this is going to give me, oh boy, okay, let's see, 4 times 50 is 200, so that's root 201. The whole thing's over 2. Okay, so this is sort of unfortunate. I think what we're going to do is we're going to go to, let's see if I can find a tab that would have Desmos in it, and oh, there it is. Okay, Firefox, and we'll go to Desmos here, and we'll erase this thing, and I have it in dark mode, so I have to do it. Okay, so if we had, let me see here, so if we had 1 plus or minus root 201 over 2, so I'm going to say negative 1 plus the square root of 201 over 2. Okay, so 6.58 or 6.59, let's say 6.5. So one of my answers here would be 6.59, and the other answer would be when I subtract. So negative 7.59. So what this tells me here, and I always want to take a second and think about this. What did I actually just figure out? I found the solutions for x. X is the smaller number. So what this tells me is, if I think about this in terms of a number line, maybe there's 0 somewhere in the middle. One of the points is 6.59, and the other point is negative 7.59. And these are my 2 critical points. So my parabola here is going to be split up into a few different intervals. Now, I would encourage people, and again, everything to the left will be 1 interval. Everything in between here will be 2 intervals, or the second interval, and this will be the third interval. I'd encourage people, of course, to think about this common sense. This is an upward-facing parabola, so I'm kind of looking back at this equation here, because this is like saying, when is this parabola less than 0? I can see it's an upward-facing parabola, so it would wind up doing this. So what I should be able to hypothesize is that the interval of values of x that satisfies it when the parabola is less than 0, it should be interval 2. That would be the winner. But if I want to be absolutely sure, I can do some test points. So I will just do a little bit of test point stuff here. Maybe I'll change color just to show the test points. And if I can find where my cursor is, there we go. So I'm going to test interval 1. I'm going to use using x is equal to, I got to pick something to the left of negative 7, so I'm going to use negative 8 here. So if I actually put that in, it would be negative 8 squared plus negative 8 minus 50. Is that less than 0? So that would be 64 minus 8 minus 50. That would be what, 6? Well, that's not true. Okay, so that tells me that this is out. That's a loser. And I could do the same thing with 2 and 3. So I could test interval 2. And what this would tell me is I would use x equals, I'm going to pick 0. So 0 squared plus 0 minus 50. Is that less than 0? Yes, that is. Negative 50 is less than 0, so that's a winner. And then I could also just test 3, and I could say we'll use, I'm going to use a value to the right of that. I'm going to use positive 8. Okay, so then 8 squared plus 8 minus 50. Is that less than 0? So that's 64 plus 8 minus 50. That's what, 72 minus 50, so that's 22. 22, is that less than 0? Absolutely not, so this one's out as well. Okay, so just as we hypothesized, 2 is the winner. So therefore, we can conclude that x, which is the smaller of the numbers, better be somewhere between these 2 values. And we're almost done, but we just have to apply a little more common sense here. So remember, x is the smaller number. So when I ask what are the numbers, I have to think about what the other one is. And I also have to look at this statement, whole numbers. So these are not whole numbers. In fact, what we're going to do is we're going to rewrite this as only whole numbers Okay, so negatives are out. So x definitely can't be negative, but it could be 0. One thing here, if you're thinking about this, x is bigger than negative 7.59. So 0 gets to be included. So I'm actually going to convert this sign to a greater than or equal to. Because if 0 is allowed, then it's got to have the equal sign. And 6.59 won't work. I have to round that to the nearest whole number. Now it can't be 7 because 7 is too big. X has to be whole numbers less than 6.59, so it's got to be, and it could include 6. So this would actually be the best way here to write this. The smaller of the numbers, x, could be between 0 and 6, and it could include 0 and 6. And then, of course, that also means that x plus 1, which is the bigger of the numbers, would be between 1 and 7. So what I could say, so therefore my final answer to kind of wrap this all together is I would say the smaller of the numbers, or maybe I would just say the first number. The first number is between 0 and 6. And if I want to include, I'm going to use the word inclusive. And if you remember, now I erased it, but if you remember back when I listed out all the possibilities, we had 0 and 1, 1 and 2, and we went all the way up to 6 and 7, giving us a product of 4 to 2. 7 and 8 was too big. 7 and 8 was 56. And 7 for the smaller number, remember that would be like x, that is outside of this range. So that should all make sense that it's working out. Okay, so the first number is between 0 and 6, and the second number is between 0 and 7. And if I really want, I can even write that. The second is 1 to 7. Okay, so that's a word problem that had a couple little twists and turns there. Is 1 and 7. The first thing, of course, was we had to define our variables. We had to write this, solve critical points. The thing which made this a little interesting is we had to use a quadratic formula, so we got some decimals, and then we had to think in terms of the closest whole numbers. We still should do the test points, even though you could make an argument that, well, I know the parabola is facing up, so it should look like that. It's still safer to use the test points. And of course, we got this, and we just had to kind of trim it down, this answer here. Okay, so next problem. The length of a rectangle is 2 centimeters greater than its width. Okay. The area of a rectangle must be less than 20 centimeters. What are the possible dimensions of the rectangle? So just like the last one here, let's take a second, think about this. We have length and we have width. Let's write down a couple things. So let's let the length equal, we could use L, but you know what? I'm going to, let's think about this. What's the easiest way of doing this? The length is 2 centimeters greater than its width, so why don't we call width x, and let's call length x plus 2, because it's 2 greater than the width. We know the area must be at least 20 centimeters. What does this mean mathematically? The area, which is length times width, so x times x plus 2, has to be at least 20. So that means it better be bigger than or equal to 20. So what are the possible dimensions of this rectangle? Okay, so one thing we're thinking about here, we're not stuck with whole numbers, so we don't have to worry about that. You can't have negatives, but that's fine. We'll deal with that later. So what are the possible dimensions of the rectangle? This is my inequality to solve, and now I'm going to turn this into, let's find the critical points. So x squared plus 2x minus 20, when is this greater than or equal to 0? And then finally, I'm going to do this. Now, one thing you might be noticing, I always like to tend to write it, I like to move everything over, but I like to leave that inequality sign there. And then on the second step, I turn it into an equal sign. I do not skip from steps 1 to 3. If you go from here straight to here, you kind of miss some of the understanding, because this middle step here says this parabola is greater than or equal to 0, which means it's above or touching the x-axis, and it's really nice to have that statement there. So I'm never going to skip that step, but I am going to show it and then end up here. Okay, so solving this. Now, is this something that is factorable? Two numbers that multiply to negative 20 and add up to 2, I don't think that's possible. So yet again, I'm going to quadratic equation. So x would be equal to negative b plus or minus b squared minus 4ac all over 2. Okay, so that is negative 2 plus or minus, let's see, 4 times 20 is 80, that'll be 84, root 84 over 2. And don't forget that simplifying radicals is the thing. So this will be negative 1 plus or minus, okay, hold on, what's root 84? So that's root 4 times root 21 equals 2 root 21. So this would be 2 root 21 over 2, so I can actually just simplify it to negative 1 plus or minus root 21. Okay, so this is not so horrendous, and you might consider leaving this in its form, but let's just work this out as some decimals. Okay, so negative 1 plus or minus root 21. This would be negative 1 plus or minus root 21. Let's get the plus. So 3.58. And the other possible answer would be negative 5.58. Okay, so this is where if you're solving this, you'd go, well, that's stupid. You can't have a negative dimension of the rectangle, but I don't necessarily know if I'd cross that out right away. What I'd do is I'd write this on a number line here. I'd say, okay, there's 0 approximately. Here's 3.58. That's a critical point. And then negative 5.58 is somewhere over here. That's another critical point. Okay, so which intervals are going to be the winners? If I want to think about this graphically, what I can do is I can look back, and again, I'm looking back to this guy here. So this is like when is y equals x squared plus 2x minus 20 above the x-axis, or touching it. So what I can see here is it's an upward-facing parabola, and it's going to do this sort of thing here. So if I'm really confident in this, and I actually am, I'm not going to worry about test points. I can actually just answer it this way. So in my intervals, I've got, remember this is like an interval, so that's interval 1. Between here and here is interval 2. Between here and here is interval 3. Well, then it turns out that the interval that is going to make me happy is 1 and 3. That's when my parabola is above the x-axis, and this one is the loser. So therefore, I can conclude that x would be anything less than or equal to negative 5.58, or x is greater than or equal to 3.58. Okay, I mentioned something about the dimensions of a rectangle can never be negative, so at this point, I'd probably say get out of here. This is out of the domain, and I might even just write length is positive. Okay, so that's just, so don't even worry about that. So this whole thing, in fact, if I really want, oops, that was an accidental bit. If this whole thing, if I really wanted on my number line where I'm drawing this, I could actually have cut it off here. I could have said this is completely irrelevant. Like that's just not even worth thinking about. Not possible for lengths. Okay, so anyway, I don't like to do that too early because I don't want to start changing things up too much. Okay, so this is my interval. Basically, x is greater than or equal to 3.58. Now, I'm not quite done because what are the possible dimensions of the rectangle? What was x again? X was width. So what I can say is I can say the width is greater than or equal to, greater or equal to, greater than or equal to, than 3.58, and I'll say centimeters. The length is same deal, greater than or equal to 5.58 centimeters. So if we just take a second, think about this common sense style. Area is length times width. So let's pick 5.58. We'll multiply it by 3.58. What do I get? This should give me the smallest value possible, which is the 20 centimeters squared. So let's just try it. Let's go with Desmos here. 3.58 times 5.58, and when I calculate that, I get 19.97. Okay, so we're just a tiny bit under 20, and you can guess why. It's because we did some rounding. So this is 19.97. Okay, close enough. So this actually makes a bit of an argument where, there's not a T at the end of that one, where instead of rounding this, you might have even left it here. And a better answer, so I'll just even write this here, a better answer, or you could say the width is greater than or equal to this, and the length is greater than or equal to 2 plus that, so this. And if you actually multiply these together, you would get -1 plus root 21 times 1 plus root 21. And the keeners among us will actually notice that this is a difference of squares. This is actually 21 minus 1, which is 20. So this actually would have been a better way, but no one talks like that, right? Okay, so there's a couple word problems. Anyway, hope that was helpful. See you on the next time.